What's going on, guys? So today we're going to do something a little bit different. We're going to figure out, how to find the distance between our parallel, Newark's parallel, and Area 51's parallel. And the point of it is so that you can find a more direct route to this parallel. So if you want to storm Area 51, you just go to the 37th parallel, and you could just like hop onto one of the ovnis or the UFOs that pass by. Anyway, so we're going to use the integral of secant, which is very important for setting direct compass headings on a mercator projection. So the integral of secant is so to find the distance between one parallel and the other. Remember the parallel is that it means the latitude. The latitude on the Earth. So that's going to be equal to the length of the Earth's equator divided by 2 pi times the integral from one of the latitude coordinates to the other times secant x dx. So in order to do that, we have to know the radius of the Earth. We have to know the parallel of the Area 51 and Newark's parallel as well. So here's what we're going to do. We're going to set this equal to L. L in our case has to be the length of the equator. We know that the radius of the Earth is about 3,958.8 miles. So we can say that it is equal to 2 pi, times the radius. So that's the circumference, right? So that's going to be the length of the equator lines. So that's going to be equal to 2 pi times 3,958.8 miles. All right, so we're going to plug this in here, and as you can see, the 2 pi is going to cancel out. So in essence, we're going to have something like 3,958.8 miles, right, times the integral from one parallel. So in this case, we're looking for Area 51's parallel. So you can storm Area 51. So it's 37.2343 degrees to Newark's parallel, which is going to be 40.7357 degrees, and then we're going to integrate secant of x dx. The integral of secant is very interesting to find. So this is what we're going to do. In order to find the integral of secant, we could do two things. So we could either do a very unusual u substitution, but to do that we have to multiply this. We have to multiply this by secant of x plus tangent of x. And so we're dividing by secant x plus tangent x. All of that multiplied by dx, and let's see what we get. So we're going to get integral of secant squared x plus secant tangent of x. All of that divided by secant x plus tangent x. Now take a look at this. If we let u equals to secant x plus tangent x, so if we let u equals to secant x plus tangent x, what is going to be du? Look at what's going to happen. Du is going to be the derivative of secant x, which is going to be secant tangent, right? So that's secant x times tangent x, plus the derivative of tangent x, which is just secant squared x. All of that times dx. And look at that. We have that in here. We have that in here, so we're going to substitute over here. So that's going to be equal to integral of du over u, which is essentially ln absolute value of u, which is equal to ln of absolute value of tangent x plus secant x plus c. We're doing indefinite integral. So indefinite integral. But over here we're doing an indefinite integral. But we already know the value of the integral of secant x. So right over here, we're going to do, so this is the same as 3,958, 0.8 times ln, right? ln of absolute value of tangent x plus secant x. And then we're going to evaluate that from 37.2343 degrees to 40.7357 degrees. All right? So this is what we're going to get. We're going to get 3,958, right? That's 58, 0.8 ln absolute value of tangent of, okay, I'm just going to approximate that in there, 41 degrees, but I'm going to put the right, okay, the exact coordinates at the end. 41 degrees plus secant of 41 degrees, and then we're going to do that. We're going to do minus ln of, okay, the absolute value of tangent of 37 degrees plus secant of 37 degrees. Okay, and as you know, okay, from the properties of logarithms, if we're subtracting two logarithms, okay, we can bring this to the bottom over here. So we can, okay, we can compress this a little bit. So we're going to get 3,958.8, okay, times ln of absolute value of tangent of 41 degrees plus secant of 41 degrees divided by tangent of 37 degrees plus secant of 37 degrees. Okay, so this, if we put it in the calculator, okay, using the very exact, okay, latitude coordinates, we're going to get about, okay, 311 miles. Okay, so that means that if you want to get to the 37th parallel, which is, you know, area 51's parallel, you're going to have, okay, something like this. So you're going to have to travel 311 miles down. So you're going to have the Earth. Okay, this is a very bad drawing of the Earth. And suppose this is America. Okay, suppose this is America. Right over here. Suppose that's America. And then let's say this is Newark over here. Okay, so that means this is going to be the 40th parallel. And then over here is area 51. So that's going to be the 37th parallel. So you're going to have to travel a vertical distance of 311 miles down in order to be at the 37th parallel. And hopefully a UFO, okay, a UFO might be able to pick you up somewhere in there, okay, because it's largely, okay, it's widely believed that UFOs, okay, like to travel along the 37th parallel. So you should probably, okay, check that out. Maybe take your private jet and go to the 37th parallel and just, you know, wait for some UFO to come back. And maybe they could take you to area 51 and finally storm it, if you wish. Anyways, if you want to know the exact distance of area 51, okay, I think you have to use a different method. You have to use Haversine's formula. But I'm going to skip that for today. If you would just, okay, if you're just curious about the exact, okay, distance from here to here, okay, that's going to be about 2,508 miles. Okay, that's going to be about, okay, the exact distance from here to here. And that's a lot, okay? So, but anyways, thanks for watching, and I'll see you next time. Please subscribe.